Okay, 5.2, day 4, we're going to rationalize the denominator. If you remember from a previous chapter, when you simplify a square root, you shouldn't have a radical at the denominator still. Okay, so we did it with the square roots before. If I have square root 7 over square root 3, I don't want the square root of 3 to be at the bottom. So to cancel the square root of 3, we multiplied by the square root of 3. If you multiply the bottom by the square root of 3, you have to multiply the top by the square root of 3. Okay, let's see what we get. This is root 7 times root 3 is root 21. If I do root 3 times root 3, I get root 9. But since root 9 is really just 3, then I no longer have a square root at the bottom, which gave me this as a better answer because there was not a square root at the bottom. We call it rationalizing the denominator because the denominator is no longer irrational. Okay, now we're going to do the same thing with roots other than square roots. Okay, so the next one looks very similar, except for instead of being a square root, it's a third root. I want the denominator to cancel out. On this one, I multiplied root 3 by root 3 because I knew that was going to give me root 9, and I knew that root 9 had a square root. Okay, so I want to do something similar here, but it's a third root. Okay, so let me think about this. Okay, I want this to be the third root of 3 to the third. I already have 1 3 here. I need 2 more 3's here in order to make this 3 to the third. Okay, let's try this and then see what it looks like. Oh, I need a third root there. Okay, now if I do this, now on the denominator, I have the third root of, if I do 3 times 3 squared, I have 3 to the third. Okay, now what do I get on the top? What's 3 squared? 3 squared is 9. 9 times 7 is 63, so I have the third root of 63. Now, if I do the third root of 3 to the third root and the third power cancel, and I just get a 3 at the bottom. On the third root of 63, I'm going to leave it as is. It doesn't simplify because it's 9 times 7. Okay, so I rationalize the denominator because on the denominator, there's now a 3, which is a nice rational number. There's no square root, cube root, any root left on the bottom. Okay, let's try C. It's the same problem. There is a cube root at the bottom. This happens to be written as a giant radical, but we could make it into little ones. I think I am. Okay, so this is like the third root of 6. Okay, now at the bottom I have the third root of 25. Now 25 happens to be 5 to the second power. So I'm going to write it like that so I can keep track of how to get this to be a third power. Okay, so on the denominator, I want to third root something to the third power. I already have 5 to the second. To get 5 to the third, I need 1 more 5. So I'm going to multiply it by the third root of 5. If I do it to the bottom, I have to do it to the top. Okay, now let's see what we got so we can see why this was a good choice. Okay, the third root of 6 times the third root of 5 is the third root of 30, and I'm fine with that. Okay, now on the bottom, I have the third root. If I do 5 to the second times another 5, I have the third root of 5 to the third. The third root of 5 to the third is just 5 because the root and the third power cancel. The third root of 30 I'll keep at the top. Okay, and this is rationalizing the denominator because there's no longer a root at the bottom. Okay, let's try some more. Okay, let's see. Fifth root of 27. Fifth root of 2. Okay, now let me see. Can I rewrite 27 as a power? What is it? 3 to the third? Okay. 3 to the third. It's better to write it as a power so I don't need to have to do 27 to the fourth. Okay, now this is 3 to the third. I want to fifth root it. Now if I want it to come out easier, how many more 3's do I need? I need 2 more. So I'm going to times by the fifth root of 3 to the second. Now if I do it to the bottom, I have to do it to the top. Okay, now why is this a good choice? Okay, on the bottom, I have the fifth root. If I do 3 to the third times 3 to the second, now I have 3 to the fifth. And then the fifth root and the fifth exponent are going to cancel. Now what do we have on the top, though? The fifth root of 2 times the fifth root of, what is that, 9? 3 squared is 9, so 2 times 9 is 18, so that's the fifth root of 18. Okay, so this is going to be the fifth root of 18 over 3. 5 times the third root of 7 over the third root of 2. The third root of 2. How many more 2's do I need to make this a third power? I need 2 more. Do it to the bottom, do it to the top. Okay, now on the bottom, I have the third root of 2 to the third, which is good because it's going to go to a 2. What do I have on the top? I have 5. The third root of 7 times the third root of 4 is the third root of 7 times 4, 28. So I have 5 times the third root of 28 over 2. Okay, and even though it doesn't look better, it doesn't have a square root on the bottom anymore. Okay, let's look at the next one. 7 times the third root of 3 over the fifth root of 4. Well, those have to match. Let's make this a 5. Okay, for F, let's consider the denominator. Can we rewrite 4 as a power? We can, right? Okay, so let's make this 7 times the fifth root of 3. For the fifth root of 4, let's make that 2 squared. If it's 2 squared, how many more 2's, factors of 2 do we need? 3 more. So that's going to be times the fifth root of 2 to the third. Okay, so in the denominator now we have the fifth root of 2 squared, 2 to the third, 2 to the fifth, which is going to cancel to 2. Now in the numerator we have the fifth root of 3 times 2 to the third. 2 to the third is 8, so 3 times 8 is 24. Okay, and now our denominator is rationalized, so we're going to take that as a better answer. Okay, for G, 7 over, let's rewrite 25. 25 is 5 squared. Okay, so since this is a third root, how many more 5's? 1 more factor of 5, top, bottom. Okay, 7 times the third root of 5 is just going to be 7 times the third root of 5. Okay, on the bottom, I have the third root of 5 to the third, which is going to go back to 5. Okay, and you don't have to skip a step there, but you can if you would like. Okay, 1 over root 6. How many more 6's? Root 6. Okay, if I do 1 times square root 6, I just get 1 square root 6, or I get square root 6. If I do the square root of 6 times 6, that's the square root of 36, which goes back to 6. And now my denominator looks better. Okay, now we're going to figure out what to do to rationalize the denominator when there is 2 terms at the bottom. Okay, so when there's 2 terms at the bottom, like 5 plus root 3, that are not like terms, we cancel them by using the conjugate. Remember the conjugate? That's when we change the sign of the irrational part. So if I look at the denominator, I have a 5 plus square root 3. To cancel it, I'm going to multiply it by the conjugate. The conjugate is 5 minus square root 3. And I know you don't know why it cancels yet, but it's going to. If I do it to the bottom, I still have to do it to the top. Okay, now if I distribute 1 times 5, I get 5 minus 1 times square root 3 is just square root 3. So I'm okay with that. Now on the bottom, I'm going to distribute this out. 5 times 5 is 25. I have minus 5 root 3 plus 5 root 3, so they're going to cancel out. And I have plus root 3 times minus root 3. So I'm going to have minus root 3 times root 3 is root 9. Which means I have 5 minus root 3 at the top. At the bottom, I have 25 minus 3. So I get 5 minus root 3 over 22. Since there's no longer a radical in the denominator, this is a better answer, even though I know that it actually doesn't look better than the first answer. Okay, let's go ahead and do the same with, for B. The problem is that there's a radical at the bottom. If I multiply by root 2, it's not going to cancel this. It's just going to make it worse. Since there's 2 terms, I multiply by the conjugate. Since this is 7 minus root 2, I multiply by 7 plus root 2. If I do it to the denominator, I need to do it to the numerator. Okay, now on the top, let's distribute. 3 times 7 is 21, plus 3 times root 2, 3 root 2. Okay, now on the bottom, I know it's going to come out nicely eventually. So 7 times 7 is 49. The 7 root 2 and the minus 7 root 2 are going to cancel because these are conjugates. If I do minus root 2 times positive root 2, I get minus root 4. Okay, I don't stop until the denominator looks nice, because apparently that's the only part we care about. 49 minus 2, which is 47 at the bottom, which is not irrational anymore. So 21 plus 3 root 2 over 47. And because there is no longer a radical in the bottom, we consider the denominator rationalized. Okay, C, same thing. What's denominator has root 7 plus root 2. Since it's two terms being added or subtracted, I multiply by the conjugate. So I'm going to do root 7 minus root 2. Since they're both radicals, it actually doesn't matter which one you change the signs on. Let's see what I get. I get 4 root 7 minus 4 root 2. I could leave it factored actually. Okay, if I do root 7 times root 7, I get root 49. The middle terms are going to cancel. Minus, if I do root 2 times root 2, I get root 4. What is that? That's 7 minus 2, which is going to give me a nice denominator of 5. Okay, last one. What's the problem? Oh, same. Root 11 minus root 2, so conjugate. Root 11 plus root 2. Okay, let's multiply the top. Root 3 times root 11. Since they're both radicals, I can multiply them. So root 33. Root 3 times root 2 is root 6. On the bottom, I get the square root of 121, which you might already figure out goes back to 11. Root 2 times root 2 is root 4, which you might have skipped all the way to 11 minus 2, which is fine. What is that? 9? Nice denominator of 9. Okay, and that we consider that a better answer because there is no longer a radical in the denominator.